Hello, this is Sonic Joshua 24. So right now, what I've been up to lately is I have been working on an operating system. Right now, I've been heavily working on a 64-bit operating system that can work on pretty much any hardware that uses UEFI. Basically, just that. So, reason why I wanted to make my own operating system is, well, a lot of things. My interest in computers, as well as my interest in wanting to make my own stuff, because I kind of like digging into how things work, because that's how my brain works. And basically, with the recent stuff that Microsoft's been doing, and obviously I'm not on Windows. I'm currently on Linux. As you can see by KDE, I've been basically just wanting to learn more about how systems work, so that way I'm not bound to one particular system, and so that way I know that I have options in case something happens later in the future, obviously. So, what I have been building is an entire bootloader for the UEFI. Now, shout out to that OS dev who has been making a UEFI application series for OS development. He does some other stuff too, but the main thing people go to his channel for is for the UEFI, which I'm one of the people who basically found his channel. So this is the first video. If you're interested in UEFI, by the way, you might want to do this first because he shows how his setup is put together, so that way you can build your own UEFI application from scratch. Because some of the other things out there to make a UEFI application use pre-existing tools. Now, you still need to use like a compiler, obviously, because if you wanted to make a compiler, I mean, that would be a whole ordeal in and of itself. But you could just use a specific Oops, that too expressive. Okay, I am Italian, so. But anyway, so basically so you could use any compiler just as long as you make sure that you design your own toolchain. Like, obviously the compiler, like you could, for example, use GCC, or you could use Clang, whichever. Now, there is a specific thing you would need to know about that, but that's what he'll go over in here on his channel. He talks about all the UEFI stuff and the binary formats that you would need to understand, like for example, there's like the MS-ABI, which is, ABI stands for Application Binary Interface, and there's also the L format and other stuff. So he'll go over some of that stuff, as well as some of the mostly a lot of what goes on in the UEFI spec. Let's see if I can find the UEFI spec. Should be in the hold folder, which is right here. I have the spec. I have like version 10 open anyway. Oh. Yeah, this was a fresh install of VS Code. Had to freshly install it. So I don't have the PDF extension installed. Pain in the butt. That's okay. So I could just go back to what I have here. So he uses different tools. What I am using, though, is I'm using a build system that is kind of different, because this build system is actually using the C compiler directly. So the build system is called Nob. It's created by this one Russian developer. I can't remember the name directly. It's like Susie Daly or something, but he created a build system that uses the C compiler directly. So if you were using make or using CMake and all that stuff, he built his own. Just so that way he could just use the C compiler directly without having to use any other build system. Now, it's because basically he just wanted to do that, and now a lot of people kind of like using it. And so I like using it too because it actually turns out to be very helpful in reducing the amount of required build tools dependencies to create an operating system. So I'm using Nob to compile everything. So for example, if I go to the terminal here, I have a build. Oh, can't see too well. Yeah. Okay. Build. So I'm going to hit enter, and it's going to start compiling and running everything within here from just this one executable that was built on Nob. So it's going to do all this. It's going to compile, and a little bit of .NET is on there because I made a kernel that is actually built with the .NET. So right now this is all C, and then we arrive at the .NET kernel. And so now I am inside my .NET kernel that has a shell. It's, supposed to be Hedge Fox OS. It just says Fox OS right now. But I can do ls, and it will do like a print of the current directory, because I have a working FAT32 driver. It only uses the short file names for right now. I'm working on the long file names for the FAT32. But I can cd into seosbl, and now I'm in the directory. I can list the directory in here. seosbl is my bootloader, which is called Simple Expandable OS Bootloader. So right now, the loader.bin is basically the binary that I'm using to actually, boot the kernel, but that doesn't contain the .NET kernel directly. The drivers is what actually has the kernel in here. So if I go into drivers, let's see what's inside drivers. So we're going to have a boot folder, a font folder, and an image folder. Now, I have my own font driver for the PSF1 font. So if I do an ls, and then I do, for example, if I do that, and then I can just look inside the font folder, let's see what we've got. We've got a PSF1 folder, so now I'm going to have to ls font PSF1 and see what it shows me here. So now we have a driver.bin, and it also shows the font that I'm using, which is zaplight16.psf. So that is what I have in the font. Now I can actually show you what I have in the boot folder. So in the boot folder, I have another folder called HedgeFox, which is HedgeFox OS, which is the kernel that I'm running. So if I do an ls and then do that again, so actually, okay, hang on, boot, and then I want to go to HedgeFox. And there we go. I have a kernel.sef. The extension SEF is simple executable file, is what I call it. So I made my own header as well, so I can show you that as well. So if I go back to my VS Code real quick, and where is that folder? All right, so I have a header.s. I'm using GCC. I'm using the MinGW GCC for Linux. And so here's my header file for the kernel. So what I have is, I have like obviously like some globals and start and some other things. So I am basically creating the ASCII header to mark that this is a specific kernel file for SUSBL to boot from, because my bootloader uses this header specifically. So what I am doing is basically I'm compiling it into an ELF format, and then I'm stripping out the header and putting in my own header. Took me a while to do all that, but basically that's what I'm doing, so that way it's my own thing. But it's still based on the executable itself is still using like a lot of the ELF stuff that's still built in. I just stripped out the header. So then I go ahead and I do a few things here. I reset the stack, and then if anything happens in here in boot, it basically will. There's a hang. Actually, I don't halt here. I found a bug. Okay, I'll have to do that real quick. Yeah. Okay. So that should. Yeah. That should hopefully halt. I'll just type it out. There we go. All right. I'll just save that real quick because I found that bug. Good thing I looked at this. All right, good. That should fix that bug. All right, anyway, so basically I reset that. So then I have a call kernel main safe. So basically this is okay. This is going to enter into the .NET kernel. I do a few things here just to make sure it's working, and then I make sure that I can print to the serial bus on QEMU. And this OS actually works on real hardware. I tested it on my Dell laptop, so it actually works there too. So now if I go to where's boot? There's boot. All right, so I have boot. So I have a few things here coming from my bootloader, because I made it so that way I don't have to recreate things multiple times. I made it so that way I can get this, and then down here I'm just calling this directly for strings and stuff. And so I'm basically, the kernel is technically like 3 kernels right now, because what it's actually doing is it's initializing 3 kernels inside one file. But I'm going to actually separate into 3 files, and so there'll be 3 kernel files eventually. But right now it's just one file. And so I make sure that the graphics is working, I make sure that my font is working, and yeah, that's pretty much what I'm doing here. So I have all of this working. We can do an lspci. So I can list out all of the hardware that I have currently. So obviously there's a display driver, there's an Intel bridge, there's the disk, and then there's another bridge, which is good. What else? What else did I put in here? Oh yeah. And just to make it a little fun, I put in a pet command. So you pet the fox. So yes. So yeah. So now, yeah, so that's basically the my OS I have so far. Took a very long time to get to this point. Obviously, I had to draw graphics and uh, get the font working and make sure to handle all the different cases, like, you know, enter and then the backspace, which backspace you have to actually also overwrite the previous character. So, like, for example, if I type something like this, if I wanted to get rid of the H at the end, I would have to, when I hit backspace, what it's doing is it sets the character back and then overwrites this area with um, um, with blank, with nothing. So basically, I'm just setting space in here, because since the font has space, I'll just basically use that. And so now the character is perfectly positioned in the correct spot. And yeah, so there was a lot of things I did. Currently, I don't have shift working right now, but that's easy to implement. I just have to be aware of if I'm holding down the modifier keys, which is space is a modifier key. So yeah, so that is it. I mean, like, let's see. I can also do help just to list the commands. And obviously there was a bug, so I don't know what the heck is up with the bug. There was a bug that happened here that got rid of this part and that part. I don't know. Okay, I'll have to look into that as well. Might be too fast or something. Anyway, so... Oh yeah, who am I? Yes. Who am I? Yes. So yeah. And then there is a built-in panic, which this would be the end of the demo because I'm basically telling the IDT, hey, we're going to do a user-created panic to make sure everything is working. So there you go. Now we have a panic message. So now it's like, oh no, the access violation in the IDT handler reached. So yes, we have reality warping because I am silly, you know. It's like basically doing stuff like I basically do an instruction pointer like thing. Basically, I'm just doing something that makes the CPU freak out, which, you know, I wanted to test. And obviously error trace message, user requested manual panic via shell. Yes, and that's how I have it set up. And since it's panic now, it's not going to do anything more, so I close the application, and then it's done. So, yeah, you can do a lot of things if you learn how a system works. And why I did .NET? Well, I wanted to see if I could do it in .NET, make a kernel in .NET, and yes, I was able to figure it out. But it took a lot of stripping out a lot of the framework's functions, so I had to stub a lot of things out. Where is it? Runtime. Here we go. So, excuse me. I usually have my screen zoomed in, but since I'm recording, I don't want to go making everyone dizzy. So, I have, in runtime here, I have a few things like the in and out. I have, so I have like a CPU halt and stuff, serial print. I have delay. I have a print hex whenever I need to look at an address. Oh yeah, and also the console actually prints out a lot of things too. So that way it's very useful for me to know what exactly is happening. If something happens, obviously. Oh, and here's my message down here. It prints down here as well. Yes. So then there's a lot of things here that I basically start messing with all the functions in .NET to stub them out, so that way the garbage collector is disabled and a lot of things, and I control a lot of it. So that way the framework doesn't go crazy and try to do something, because it doesn't have since it's not running on a pre-existing operating system. Since it's not running on a pre-existing operating system, because it is the kernel itself, it doesn't have its own malloc. It basically has to use what I created, which is like a memory allocator and frame allocator and memory mapper and stuff like that. So, and then because of how I designed it, I also have the different sections like hardware and memory and messaging, because I am using IPC. So the messaging part right here, I think this is, yeah. So here, basically, this is where the interchange of communication is being sent to for each kernel. This is oh yeah, so this is a helper, so that way I can send the IPC requests. And then a few other things, like in settings, I'm basically grabbing all the information that I already had set up in the UEFI bootloader. So that's all of this. And then I also have threading right here, which is a thread. And so yeah, I did all of this in .NET. And some of the things required me to also put some of the functions in C files, because if I don't, the framework is actually going to end up in an infinite recursion loop and completely smash my code with the stack. As it was very much a pain in the butt to diagnose, because it's like, what the heck is going on? Kind of thing. Where is it? There should be a .NET.c. There it is. Okay, yeah. So this one function right here that I had in the runtime.cs file before, it kept calling this, because what this does is it basically switches between managed code and unmanaged code. So a lot of it I'm using unmanaged code, but some of the things I'm able to use managed code for. So when I would switch between those two states, two ways of execution, this function would run. And when it was inside the framework itself, inside runtime.cs, this would cause an infinite loop, because it would then be constantly switching between managed and unmanaged constantly whenever I tried to do something. So I had to actually place it in a C file instead. So this is why I have a .NET.h file. And so I am also stubbing out a few of these, because these caused issues as well, which is a pain in the butt. But that's okay. Sometimes you have to do that in order to get things to work. Yeah, but this proves that you could use really any language to create a kernel, but at the same time, you basically, you can use any language, doesn't necessarily mean that the particular language you're trying to use would be good for kernel development. Now, obviously, .NET has been fighting a little bit, but I have actually figured out why, and so now everything is actually starting to work out, which is great. But if I wanted to, I could try and be someone who is really insane and try to get TempleOS code to work. Now, that would be nuts, and a whole nother can of worms I would have to dig into. But I wanted to just use .NET and see if I could get it to work. And that's pretty much what I did. So that's pretty much all I have for the whole demonstration of the OS and it being possible to create a OS kernel from the .NET, which is possible. And it's a pain in the butt. Plus, also use native AOT because if you don't use native AOT, it's not going to work, obviously. So I hope you enjoyed that. Obviously, this was obviously all unscripted, so basically, I just had a rough idea of what I wanted to show. And so that is it. Thank you for watching.